All right, awesome. Now we get to talk about functions. Cool. So here's the definition of a function. A function is a relation, and a relation, just as a side note, is just two ordered pairs, just a set of ordered pairs, just two numbers or variables or items that relate to each other. It could be anything at all. So a function is a specific relation in which for each distinct value of the first component of the ordered pairs, there is exactly one value in the second component. All right? Yeah, right, exactly. You know, when you read some of these definitions, you just look at it and it just spins you around in circles. Okay, so here's what a function really is. If I have a function, yeah, this all sounds good, but a function really means that your x's can't repeat. Aha, that's what I want you to know. So yeah, this is a nice definition. However, what you really need to know about a function is the fact that your x's can't repeat. That's all the business, and the definition says first component, exactly one value in the second component, all that crap. What you really want to know is the fact that your x's can't repeat. So determine whether or not you have a function. Look to your x values. If they repeat, you're out. If they don't repeat, then you're good. Then that one's a function. That's it. Pretty cool, right? All right, let's look at this function. I have function f, which is just a set of ordered pairs. So you have the ordered pairs 1, 2, -2, 4, and 3, 4. I want to determine, is this a function? Now, what am I looking for whenever I'm looking for function? Just the x's. Right now, do we care about the y's? No, poor little y's, we don't care about you. In order to determine if this is just simply a function, I'm looking at the x's. Do the x's repeat? No. So, is this a function? Heck yes, it is. So, we do have a function here. Even though the 4's repeat and the y values, right now that does not matter. The only thing I'm concerned about are the x's. Good. Awesome. Now, anytime you have a relation, not necessarily just a function, but any relation possible, you are looking at your numbers within there, and they can be broken into categories. The two categories that we are looking at specifically are the domain and the range. So the domain of a function are your x values. And the range of a function are your y values. So if I'm looking at my x values and my y values, if you're wondering, oh, how do I keep track of that stuff? Remember it alphabetically. X comes before y in the alphabet and D comes before R. So I don't know if that may help or not, but that's just a slight little mnemonic device. Also, there are two criteria that are associated with your domain and range. The first criteria is that it has to be in numeric order, meaning small to big. So when you write the values out in your domain, you have to put them in numeric order. The second criteria that you have for your domain and range is that you can't repeat values. So even if you have numbers that repeat in the domain and range, you do not repeat whenever you're laying it out. Pardon me, if you have numbers that repeat in your relation, because it doesn't necessarily have to be a function, just a relation, and you can get the domain and range, then you do not repeat them when you state your domain and range. Basically, the domain and range is just a list of what you got going for you. It is not how they relate to one each other. That's what you do in your original problem. The domain and range is just listing it out. Hey, here's all the x values possible. Okay. Here's all the y values possible. Okay. And then your relation is going to see how those x's and y's work together. Cool. Let's try one here. For this relation, we don't know if it's a function yet or not. We're going to determine that. For this relation, we see that G is the ordered pairs 1, 1, 1, 2, 1, 3, and 2, 3. So we have a couple of questions that we want to ask. First of all, is this a function? And then, regardless of whether it is a function or not, we are going to state the domain and the range. So, first of all, is this a function? That's right, negatory, good buddy. I have ones repeating all over the place. And the only thing I'm concerned about when it comes to a function is whether or not the x's repeat. And they are. They're repeating the dickens out of this thing. So no, this is not a function, but it does not matter if it's a function or not. You can still have a domain and range. So the domain is just a list, and remember it's in numeric order. So my domain is going to be 1, 2, and my range is going to be 1, 2, 3. Now notice I have a different number of values in my domain and my range. That's fine. All the domain and range really is just listing out what are those values. Now, those are supposed to be squiggly brackets around the domain and range. I'm not very good at drawing those, especially on the iPad here. So work with your squiggly brackets, just do the best that you can. If you're just listing out, it's called set notation, and that's whenever you put in your squiggly brackets. Cool, let's do more. Okay, for these next couple of problems, we're going to give the domain and range, and then we're going to tell whether the relation is a function. Now, so far we've just looked at problems like this, where we have points. So I have the point 3, negative 1, 4, 2, 4, 5, and 6, 8. So I have those different points that I'm looking at in my relation. So let's make the determination. Is this a function? Yes or no? No, good, because these 4s repeat. So nope, not a function. But regardless of whether or not it's a function, we can still state the domain and the range. What's the domain of this function? 3, 4, 6, good. What's the range of this function? Negative 1, 2, 5, and 8. Good. Now, these happen to be in order, but if they're not in order in your problem, make sure you're rearranging them when you state the domain and range for the order, because remember that's part of domain and range. Cool. Another way that we can look at problems is called mapping, where I have two sets of values. So here I have 4, 6, 7, and negative 3. And I have 100, 200, 300. 4 goes to 100. 6 goes to 200. 7 goes to 200. And negative 3 goes to 300. So mapping is when you have an arrow that points to the value it's associated with, not just writing it out as coordinate points like what we've seen in the past. So this is just mapping is what that's called. Now, I want to look at this and say, okay, is this a function? Yeah, because every single x value or input value goes to a single output. Now notice the 200 is repeated because it has two arrows pointing to it. But if that's in the y column or the output value, does it matter? Nope. What would it look like if I had a problem here with whether or not it is a function? Yeah, I would have like 6 also goes to 100. If it repeats in the x's, that is what makes it not a function. Okay, cool. Cool. But that's not the case for me here. So I'm going to get rid of that arrow. All right, and we still just have my 6 going to the 200 and the 4 goes to the 100. Okay, good. So function, yep. Now I want to state the domain and the range. My domain, remember this is in numeric order. So it's going to be negative 3, even though it's at the bottom, 4, 6, 7. And my range is 100, 200, 300. Perfect. Good. Let's do one more right here. So if I have a T-chart, that's another way to show a relation. So I have negative 5, 2, 0, 2, and 5, 2. And I'm going to run the gambit again. Is it a function, yes or no? And then we're going to state the domain and the range. So is this a function? Yeah, because -5, 0, and 5, none of those repeat, so you betcha. What is my domain? -5, 0, and 5, good, because those are my x values. And what is my range? Simply 2, good job. So my range here is just a 2, and it's okay that those repeat, because the only thing that determines whether or not I have a function is if the x's repeat. Awesome, you guys are doing great.